Gauss law. This law relates the flux through any closed surface and the charge enclosed by the closed surface. So it relates the flux through any closed surface in an electric field and the charge enclosed by the closed surface. These two factors are just related to each other. That is called Gauss law. In order to understand Gauss law, first we want to understand what is meant by electric flux. Electric flux is denoted by phi. To understand the electric flux, consider an electric field, uniform electric field E. In this electric field, consider a closed surface S. Now draw a normal to this surface. Draw a normal to this surface. The normal makes an angle theta with the electric field. Now we can define this electric flux. The electric flux is defined as the total number of electric lines of force crossing this closed surface. That is called electric flux. In order to find an expression for this electric flux, now let us consider a small elemental area ds. A small elemental area ds in this closed surface. The normal to this elemental area is n. This n makes an angle theta with the electric field. The flux through this elemental area, let it be d pi. The flux through the elemental area, let it be d pi. D pi is equal to E vector dot ds. We can put it as vector symbol since the normal has some direction and the electric field is a vector quantity. So this is called the flux through the small elemental area. So the flux through the entire closed surface in the electric field is, we can have d pi integration surface integral E dot ds. This can be pi is equal to integration E dot ds. So this is known as electric flux. This E dot ds, we know that both are vectors. If both makes an angle theta with each other, this E dot ds can be replaced as E ds cos theta. Why we want to replace? Because in vector cos theta is equal to E vector dot ds vector divided by modulus E modulus ds. Then cross multiply. E ds cos theta is equal to E vector dot ds vector. So that's why E dot ds can be replaced by E ds cos theta. So this is called as electric flux. So finally we can tell that what is meant by electric flux. The electric flux through a closed surface in an electric field is defined as the total number of electric lines of force crossing this closed surface. Then that is called electric flux. Now we can go for this Gauss law. Now you can understand what is meant by electric flux. We can just go to the Gauss law. So what this Gauss law tells, already I told, this Gauss law relates the flux through the closed surface and the charge enclosed by the surface. So the Gauss law states that Gauss law in mathematical form we can express this Gauss law is the total flux linked through a closed surface is equal to 1 by epsilon naught times the net charge enclosed by the surface. This Q is called the net charge enclosed by the surface and 1 by epsilon naught times the net charge enclosed by the surface. So this is the surface, closed surface in an electric field. In an electric field, the total number of electric lines of force through the closed surface is numerically equal to 1 by epsilon naught times the net charge. So this surface will enclose net charge. 1 by epsilon naught times the net charge enclosed by the surface closed by. This is called Gauss law. What is epsilon naught? This epsilon naught is nothing but permittivity of free space. Permittivity of free space or air. Permittivity, physically we can tell that, we can interpret that the permittivity is how much electric field that free space can allow. That is called permittivity. So the total electric lines of force through any closed surface is equal to 1 by epsilon naught times the net charge enclosed by the surface. So this expression, if you see that this expression clearly relates the flux through any closed surface and the charge enclosed by the surface. This is called Gauss law. So there are many applications of Gauss law. One of the applications is using Gauss law, we can find electric field due to a current carrying conductor. That electric field at a point nearby to the current carrying conductor we can find. So one of the applications of Gauss law is called Gauss law.